Alright, here's an application. It says the minute hand of a clock is 3 inches long. How far does the tip of the minute hand travel in 50 minutes? So if you drew a clock, let's say it started up here at the top, and it went around like 15, then 30, then 45, and then 50 minutes. So in a way it kind of looks like that, kind of looks like a Pac-Man in a way. So this is 55 minutes, but I need to somehow, because they ask me, just like any other sector problem, we know that the minute hand will end up being the radius, so the radius is going to be 3. They're asking me to find the arc length, really, because that's how far that minute hand travels as it goes around. But they didn't really tell me the angle, they just told me that it was 50 minutes. So that's a certain portion of an hour, so 50 minutes out of, if you went all the way around the circle, it would be 60 minutes, okay? So it'll be 50 over 60. At this point you have a choice whether you want to do it in degrees or radians. Since the formula, if you do it in radians, is just S is equal to R times theta, that formula is so much easier than the degree one. If I have a choice, I'm going to go ahead and just do it in radians. So to figure out what this is in radians, it's just a portion of the entire circle. In radians, all the way around a circle is 2 pi. So this will just be 50 over 60 times 2 pi. So I'm just going to simplify this a little bit. The zeros cancel. This is like a 1 underneath. If I multiplied straight across, I would get 5 times 2 pi would be 10 pi over 6. And I guess I could have reduced that before, like here to here, but I'll just reduce it now. 10 pi over 6 reduces to be 5 pi over 3. So this is what my theta is going to be. It's going to be 5 pi over 3. There's my formula right here. So arc length will be equal to my radius, which we said was 3, times theta, which is 5 pi over 3. If you notice in this particular case, the 3's cancel out, so I just get that S is equal to 5 pi. And that's the answer.